So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So today we'll be discussing section 4.6, uses of an oscilloscope. A cathode ray oscilloscope is a laboratory instrument that is used to display, measure and analyze waveforms for electrical circuits. If you have an AC current on an oscilloscope, it is represented as a transverse wave, so you can determine its frequency and amplitude by looking at the pattern generated on the screen. The x-axis is always the time and y-axis is known as the y gain, as the voltage or the y gain. See, this type of wave is usually formed on an oscilloscope. Now remember, in O-level physics you do not need to know the structure of oscilloscope, you simply need to know its uses. So from over here till here, this would give you one wave or one wavelength that is represented by lambda. This is the second and this is the third, and time by base usually means that how much time is represented by one division or one box. The period of the wave can be determined from the time base. This is how many seconds each division represents. Now this is usually given in seconds per division or seconds per centimeter. Use as many wavelengths shown on a screen as possible to reduce uncertainties. Dividing the total time by the number of wavelengths will give you time period. That would be the time taken for one complete wave or one complete oscillation. And then you can use it to find the frequency. That is, frequency is supposed to be 1 upon t multiplied by 1000, so that it is converted from milliseconds to second. Y gain. What is Y gain? This is basically the amplitude on your screen which amplifies the deflection of electron beam. The amount of deflection depends on the input voltage at Y plates. It also determines the sensitivity of the oscilloscope. Its unit is volt per division. A Y gain of 1 volt per division means that for an input of 2.5 volt, the deflection would be 2.5 divisions, or your wave would have an amplitude of 2.5 units or 2.5 divisions. Time base, when time base is on, a voltage is applied to the X plates. Time base controls the speed at which the electron beam sweeps across the screen from left to right. This is done by altering the frequency of the time base. The more frequency you have, the you can say the greater your or the more dense your pattern would be on screen. This is done by altering the frequency of time base. Its unit is milliseconds per division or hertz. See, if you have low frequency, there would be less dots. If you have higher frequency, the dots would be shown on the screen so fast, the beam would be moving so fast that you'll see a line instead of simply dots. How do you convert between milliseconds per division and hertz? Time-based frequency is 25 hertz, which means that the electron beam sweeps across the screen 25 times in 1 second. Each screen has a fixed number of divisions that will be given to you in form of a grid in the question. This means each time the electron beam sweeps across the screen, it would move 8 divisions. Over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over here we have 10 divisions. So therefore in 1 second it would sweep across 25 into 8 equals to 200 divisions, or we if we are considering this image, we would say 25 into 10, 250 divisions. So time base would be equal to 1 divided by 200 equals to 0.005 seconds per division, or 5 milliseconds per division. Or if you are using the very first image, means having 10 divisions, then it would be 1 divided by 250, that would give you 0.004 seconds per division, or 4 milliseconds per division. Note that the y gain and time base are similar to the scale of a graph. Y gain is for y-axis, whereas time base is for x-axis. So the greater scale you have, the bigger would be your graph, and so on. Applications of CRO. The first application is to measure voltage. When time base is off, CRO can be used as a voltmeter. Since time base would be off, then you would have a single dot that would be reflecting the amplitude of your input current. If it is DC, if it is AC volt, then you'll see a straight line having the maximum amplitude of whatever is your voltage. See, for 2 volt per division and AC of 3 volts, this is the mean line, and it would show you 1.5 divisions above the mean line. Whereas when the Y gain was 1 volt per division, then from the mean line there was a line 3 volt above, 3 divisions above and 3 divisions down, because each division represents 1 volt. So 1, 2, 3 volt, and since this is AC, minus 1, minus 2, minus 3, from 3 volt till minus 3 volts, this is the range of the AC. Whereas in DC we have fixed voltages, so this is the mean line, and 1, 2, 3, 1 volt per division, and the dot is at 3rd division. The voltage to be measured is applied on the Y plates or the Y input terminals. An electric field is set up between the Y plates so that electron beam would sweep toward the positively charged Y plates. The deflection of electrons is proportional to the applied voltage. By adjusting the Y gain, the height of trace can be magnified so that its magnitude is easy to be read. See, over here it might have been difficult, so you increase the Y, so you change the scale. Now it is easier to read that the input voltage is 3 volts. The second use of CRO, displaying voltage waveform. When time base is on with a suitable frequency, a steady waveform can be displayed on a screen. The period of each wave, number of complete waves can be varied, and it is determined by the formula number of cycles equals to frequency of AC input divided by frequency of time base. This type of pattern you would see, for example, if the time base is 100 hertz and Y gain is 1 volt per division, and this was supposed to be 6 volts, so 1, 2, 3. So this type of, see, the frequency is lower. Over here the frequency is less, so you'll have more waves. Measuring short intervals of time. When time base is on, CRO can be used to measure a short interval of time. One of the examples is to measure the time taken for sound to travel a distance and find the speed of sound. How do you do that? Set up the apparatus as shown. This is the CRO and you connect it with a microphone, and then you transmit a sound, and then you put up some sensor to catch the reflecting sound. This would usually be given to you in the question if such a question comes. Now the microphone first produces a pulse of sound, and this would be the first pulse on the CRO. This would usually be larger. This would give you a larger peak on screen, and after some time you'll have a smaller peak on the screen that would be caused by the reflected sound. The distance between the two pulses is actually the time taken for the sound to travel the microphone to the wall and come back. Thus the speed of sound is 2d, means 2 multiplied by distance. Why 2d? Because sound traveled from here to here and then it came back. So basically it traveled twice the distance divided by time. How would you find time? Simply count the number of boxes and you would be told what is the time base, so multiply it with it. Note that the height of the sound pulse is smaller than that. The second pulse is smaller because some energy is lost to the medium and the reflecting wall. This is a screen display summarized. If you are having a DC supply connected and the time base is on, you are going to get a dot. This is on, you'll get a An oscilloscope is used to measure potential difference. The trace with no input is shown. So this is at 0. This is the y-axis, this is the x-axis, or this is the time base, this is the y gain. As you can see, the dot is in the center, means at 0. 1.5 volt DC which trace shows a supply of 1.5 volt. 1.5 volt would mean that you if one box shows 0.5 volts. So 1.5 means you have to have an amplitude of 3 boxes, or set it 0. Means supply 3 divisions above, so that means only C can be the answer. In a magnetic field, the coil is connected to an oscilloscope. The diagram shows the trace on the screen of oscilloscope. The coil now speeds up and rotates twice as fast, which diagram shows the new result. If it moves twice as fast, that means it would produce twice the amount of current, so that means the amplitude would be greater or double, and if it is moving faster, it would be, that means its frequency has been increased, so B would be the answer. As the coil rotates at twice the speed, its frequency is doubled and it would produce the twice the amount of current, so amplitude will also be greater. A microphone detects a musical sound and the signal is fed to an oscilloscope. The diagram shows the trace, this one. The spot of light, it takes 1.5 milliseconds to travel across the screen. So in 1.2 seconds we have one complete wave and two complete waves. So in 1.2 milliseconds, if it is producing two complete waves, that means the time taken for one complete wave would be 0.6 milliseconds. What is the frequency of the musical sound? Now what we need to do is, obviously we need to use the formula, frequency equals to 1 upon time. So 1 divided by 0.06 multiplied by 1000 would give us something like 16,000. Sorry, I added an extra 0. 1 divided by 0.6 1 divided by 1 divided by 0.6 divided into This would give us something like 1666.66. Now we don't exactly have that option over here, but C would be our closest answer to that, hence C is our answer. A loudspeaker and a microphone are placed in front of a wall. The loudspeaker makes a sound which is detected by the mic. They are connected to an oscilloscope, and the division is 0.01 second per division. The microphone detects original sound and echo, and these are the two peaks. As you can see, this is for the sound, it has greater amplitude. This is for echo. Now how do you the speed of sound in air is 300 meters per second. Now how do you find the time between these two? Simply count between these. Either start counting from the start of the first peak till start of the second peak, or count from middle of the first peak to the middle of second peak, or count from the end of first peak to end of second peak. So let's count 1, 2, 3, 4, 5, 6, 7 and 8. I'm counting until end. So we have 8 divisions, and we know that this is the reflected sound. That means this is this is the total time for twice the distance. So how do we find that? Simply apply the formula. Speed equals to 2d upon time. So speed is 300 multiply by time, that is 8 divisions means and 1 division is of 0.01, so 0.08 divided by, since we use 2d in the formula, so we'll divide it by 2 and the answer would be 12. B. If you are confused, I'll write the formula for you. And speed is 300 equals to 2d we don't know, divide by time we know 0.08. Now 300 divided by 0.08 would be equal to 2d, and then this is 24 divided by 2 would be equal to d, and 12 would be our answer. That's it. That's all you need to know for section 4.6. I hope you have understood all the concepts and everything is clear. Please do leave comments. If you have any problem, I'll make sure to reply them. I'll see you guys in the next lecture. This concludes our section number 4 entirely. Good luck for your CIEs. Take care. Allah Hafiz.